But first, let's start with the definition. We have a polynomial in one variable. It's going to be in the form of a sub n times x to the n, a sub n minus 1 times x to the n minus 1 plus blah, 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 so on, right? Goes all the way to a sub 0. X is a variable, and each a sub I, in this case, a sub n minus 1, a sub n minus 2, so on, is a constant. And these ones here with the variable is called the term, and a sub n or a sub i's are the coefficient of the corresponding x to the I. The important part here now, the degree of the polynomial is the greatest integer n, such that the coefficient of a sub n is not equal to 0. So meaning that if a sub n is not a 0 here, then the degree of this polynomial is simply n. A sub 0 is our constant term because it's times x to the 0, which is 1, right? So that's why we say that, so is a sub 0 here is called the constant term. Okay. And we find the constant term when we plug in 0 for x, right? If I want to find this a sub 0 here, that means I want all the other terms to be gone. So, and to do that, all we have to do is plug in 0 for x here. And we call this, we call polynomial a monomial if there is only one term. It's binomial if there are two terms. Where I come from, again, the term bi, right? It means two terms. And when we have three terms, it is called trinomial. So when we say 3x to the 4, there is a quadratic monomial. 2x squared plus 1, it's a binomial, that's a quadratic. And here we have a trinomial with a degree of 5. Okay. And we call the degree of this polynomial is 5, and the coefficient for x to the 5 is called the leading coefficient. Okay. Again, we go over again, n is the degree, leading coefficient, the constant term. Now, when we cover polynomials, there are two things we are interested in. What is the remainder when we divide a polynomial, and the roots, right? So if we divide a polynomial with another polynomial, then we care about what is the remainder from that more than the quotient itself. And then the other part is, what are the roots of a polynomial? Now, if when the polynomial f of x is divided by the d of x, then we get a quotient q of x, and the remainder is r of x. You might say that, well, why is this a function of x, right? So first of all, we don't know if it's a function of, it is going to be a function of x, but it can also be just a constant as well. Now, r of x is equal to 0. That means that f of x is divisible by d of x. And remember, guys, when we divide two numbers, for example, if I divide a number by 3, I know that the remainder can only be 0, 1, or 2, right? Because if it is 3, you can continue to divide again. So with the polynomials, if you are dividing a polynomial with a quadratic, which means a degree 2, the second degree equation, right? That means your remainder can either be a constant or it can be a linear equation, right? You cannot assume it is going to be constant. Okay. So when we say that, okay, so whatever the degree of your divisor, the remainder degree has to be less than that. For example, let's take a look at here. F of x is given as x minus a times q of x plus r. I'm dividing it by x minus a. If I divide it by x minus a, which is a linear equation, then that means the remainder has to be a constant, right? Because this one has a degree of 1, though the remainder has to be a degree of 0, which means a constant, right? I hope it makes sense. And now, again, like I said, we are interested in finding that remainder. To find the remainder, we are gonna, that means I do not care about this part now to find the remainder, right? And to get rid of this, because Q of X can be any degree of polynomial. Let's say F of X is a degree of 90, then Q of X can be a degree of, the quotient can be a degree of, let's say, 98. But I don't care about any of these, right? All I care about is what is the remainder. Because we are dividing it by a linear equation, the remainder is going to be constant. And because we don't care about this, the easiest way to get rid of it, rather than finding what makes this 0, it is easier to find what makes x minus a 0. And that is going to be when x equals a, right? So this is going to be gone when x is equal to a. Why? Because if you plug in a for x, then we get f of a is equal a minus a times q of a plus, again, the remainder, we don't know what that is, let's say r of a, right? So a minus a is 0, so this is gone. So f of a is equal to r of a. But remember, this is a linear, so this is simply just a constant, right? That will give us a constant. Okay. I hope it makes sense. We're going to come back to this when we talk about the roots. We're going to talk about the Vieta's formulas, but first let's cover this, and then we will go back to Vieta's answer. Now, if you take a look at the example 1 here, this is again covering the basics. With example 1, the question says that, again, this comes from the definition of the polynomials. It is given that f of x is an x cubed minus 4x plus 7, and g of x is negative 3x cubed plus 2x squared plus x minus 7. The question says find f of x plus g of x or f of x minus g of x. And the question says for what value of c, the sum of this have a degree of 2. First, let's add the polynomials, right? Remember, when we add the polynomials, remember the like terms, right? We have to combine the like terms. So let's start with that. We know that we have x cubed minus 4x plus 7 is our f of x plus negative 3x squared plus 2x squared plus x minus 7. Okay, as you can see, we have x cubed minus, so this is a cube, my cube look like a 2. So x cubed minus 3x cubed, we just add the coefficients. So we will get what? 4a, we're gonna get negative 2x cubed. There is no x squared term on the f, so that means my only x squared term is gonna come from g of x, which is 2x squared. There is negative 4x, here is an x, so minus 3x, 7 minus 7 is simply 0. Okay, so here is our f of x plus g of x. Now for parts B, we are asked to find the difference, right? Again, x cubed minus 4x plus 7 minus negative 3x cubed plus 2x squared plus x minus 7. Now, I know that students already know this, but it doesn't hurt to remind them. When we subtract it, there is a negative here, right? So we need to pay attention to the sign. And I can tell you that probably more than like about 60 to 70% of the students will make a careless mistake there. Okay? Again, x cubed minus 3x cubed, we get 4x cubed. Like I said, there is no x squared term, so we have minus 2x squared, negative 4x, negative x, negative 5x, 7, now it is plus 7, which is plus 14. Okay. So this is very, this is straightforward for students who are in level 1, where they can cover A and B. But for part C, it's a little bit more challenging. Now the question says that we want this to have a degree of 2. So then I asked the students to question, what do they mean by degree of 2? If I want the sum, which we found here at some point, we found the sum, right? But there's a C here, so it is not just adding them, but adding f of x plus c times some g of x have a degree of 2. Now, what do they mean by degree of 2? That means because when we add f of x and g of x, we get a cubic polynomial. But this time we only want degree of 2. So then students usually answer that they say that, oh, if there's a degree of 2, that means 3 has to be gone, right? So that, like I said, so students try to write the whole thing out, x cubed minus 4x plus 7 plus negative 3cx cubed, and then 2cx squared plus cx minus 7c. But I remind them that I do not care about any of this. All I care about is x cubed to be gone. Okay, so unless c is 0, I do not care about anything else here, right? Okay. Now, take a look at, so that means they did not really need to write any of this. All they need to care about is the x cubed minus 3cx cubed, right? And we want this to be a 0. So you can factor out x cubed, 1 minus 3c. Again, we want the coefficient to be 0. So therefore, 1 minus 3c is 0, and c is 1 over 3. And the question says x is a decimal, so it is 0.333. Okay. Again, they don't need any of this. It will save them a little bit of time on solving the question. Okay, let's move on. I hope this makes sense. If there are no questions, we are going to move on to example 2. For example 2, the question says that there is a polynomial, and then it's such that x minus 1 times f of x is 3x to the 4 plus x cubed minus 25x squared plus 38x minus 17. So find f of x. Now, so we asked them, how do we start the problem? Right? We are asked to find this f of x. I tell them that normally, if I tell you that, for instance, 2 times x equals 11, then to find x, remember we divide both sides by 2, right? Then we get that x is 11 over 2. Similarly, here you can say that, well, I want x f of x, so I need to get rid of x minus 1. Maybe we can divide both sides by x minus 1, right? Then let's see, how do we get, so they can say, well, let's divide by x minus 1, this whole thing by x minus 1. Okay. Now, you can say, well, this side is f of x, but then the right-hand side, 3x to the 4 plus x cubed minus 25x squared plus 38x minus 17 divided by x minus 1. Now, most students, first they will try to see if they can factor it, right? But oh no, it's a quartic, which is like a 4th degree polynomial on the top, and that is not very easy to, I mean, this is not very obvious, right? We cannot just start factor them, but I mean, they will attempt, which some of them they might, right? Or they can say, well, we can do long division here, right? Okay, but if you do long division, it might still take them some time to do this. Okay, so then we ask them, well, maybe instead of doing this, so again, I let them suffer a little bit, try to do the long division or try to factor it. After that suffering, and then they're like, oh, I give up, I don't, then maybe they need the idea, maybe there's a better way to solve this. Right? So we look at so rather than dividing, let's look at the right-hand side. We can see that the right-hand side is a 4th degree polynomial, and the left-hand side is x minus 1 times something, right? So that means f of x, for me to get a 4th degree on the right-hand side, then f of x degree has to be what? The degree of f of x should be, because I'm multiplying by x, should be x cubed, right? So we can say, well, the degree of f of x should simply be 3, right? So we can say that, well, then f of x can be in the form of ax cubed plus bx squared plus cx plus d. And then we are multiplying that with x minus 1. Okay. So it's ax cubed plus bx squared plus cx plus d is equal to 3x to the 4 plus x cubed minus 25x squared, 38x minus 70. Now, we may not do much on the right-hand side, but on the left-hand side, we can easily multiply this, right? So we can say that I get ax to the 4 plus bx cubed plus cx squared plus dx. Because multiplying all this with x means increase the exponent of x by 1. Then minus ax cubed minus bx squared minus cx minus d is equal to the same thing again here. We copy it. Okay, and then we just found a, right? Because you know that the left-hand side is ax to the 4, right-hand side is 3x to the 4. So that means a is equal to 3. Now, the only thing that the left is make sure the x cubes are equal. I mean, the coefficient of x cube is equal, x squared is equal, and so on, right? So then we'll move on to the x cube. So we have bx cubed, negative ax cubed, and then just 1x cubed here. Remember, I just found that a is 3, right? So we know that b minus a is equal to 1. Remember, a was 3, therefore b is 4. Now we are done with x cubed, or we already found b. Now let's take a look at x squared. So we know that c minus b is equal to negative 25. Remember, b was 4. So that means c is going to be equal to negative 21. And then we move on to the x1. So we have dx minus cx. So we get d minus c is equal to 38. C was negative 21. Negative and negative makes it a positive. So d is 38 minus 21, which is equal to 17. And finally, the coefficients, we didn't even need to do that, right? They noticed that the constant has to be equal. So negative d is equal to negative 17, so d is 17. So we are done, right? So we just found f of x. We know that f of x is equal to 3x cubed plus 4x squared minus 21x plus 17. Most students can see a is 3, d is 17 because of the constant and the leading one. Then they have to figure out this. Again, there is nothing wrong with x minus 1. They can divide with x minus 1. But this example, we wanted to show the equality of the polynomials. Okay. I'm going to skip this part now. Again, like this, we're going to skip this. Now let's take a look at here. Again, by the way, during the class, I don't skip. Just for today, okay? So, for example 6, we are given that p of x is a polynomial. We are given this very ugly looking polynomial on the left-hand side, right? Like x to the 23, 23 times x to the 17. I mean, we cannot we can factor x to the 14, but still, this is not very nice to find the roots. So I have a question. You can divide by x minus 1, but that takes longer. But there's nothing wrong with it. You can just still do that. There's nothing wrong with it. We do divide, like students do divide by x. But I show the division of the polynomials, long division, later on, like with different methods. Okay, so in the p of x here, I hope I answer your question, Nana. Okay, so in the polynomial here, so the question is asking for sum of the coefficient of p of x. So we don't, so when the question says sum of the coefficients, you can find p of x, right? Or, and then add the coefficients. Or maybe, like, for instance, like this question, I don't want to divide it, right? Like, I mean, it doesn't mean you cannot, I just don't want to. Okay, now, let's see here. If I want to find the sum of the coefficients, maybe there is a better way to do this, right? And you know those, in TV commercials, the guy is trying to do a task, it takes longer, it gets messy, and they say, wait, there is a better way to do this. So same thing here. There's a better way to do it. Find the sum of the coefficients rather than finding p of x. Now, remember our first definition? P of x is something like a sub n to the x to the n, a sub n minus 1 times x to the n minus 1, blah, 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 a sub 1 x to the 1, a sub 0. I'm only interested in finding what? A sub n minus 1, a sub n minus 2, all the way to a sub 1 plus a sub 0. Now, if I just want to add these ones, then what do I want x to be? For what value of x? Yes, Wesley, that is correct. Thank you. So we are thinking that for what value of x we can get a sub n minus 1 and so on, right? You can say, well, 0, if you try 0, everything is going to cancel and you will just find a sub 0, right? Which is the constant term, which is great, but we are not interested in that. Now, if you plug in 2, 3, well, we don't know what the degree or what are the other coefficients. The easiest one is, so we are going to find the value, no matter what you plug in, no matter what n is, we know what the value is, right? And that one is, like Wesley said, x equals 1. So when x equals 1, we have p of 1, then you get what? A sub n, 1 to the n is 1. 1 to the n minus 1, still 1. Then all the way to x to the 1, still 1, plus a sub 0, right? So there you go, here we got the coefficient. So that means you want x to be 1 here. Then if x is 1, let's plug it in, right? Okay. Plug it in. So we know that we want x to be 1. So here 1 to the 23, 23 times 1 to the 17, minus x times 1 to the, minus 24 times 1 to the 15, plus 108 equals 1 minus 3 times 1 minus 2 times 1 plus 9 times p of 1. And this is what I want, right? So the right-hand side is left-hand side is gonna be 1 plus 23 is 24, minus 18 is 6, 6 minus 24 is negative 18, plus 108, I believe this is 90. If I'm wrong, which I've been in the past, please let me know, okay? Please do not be mean and do not wait for me to finish everything and then tell me, well, you had it wrong. Don't do that, okay? Just tell me. So we get 1 minus 3 is negative 2, negative 4, plus 9 is 5. 5 times p of 1. So therefore, p of 1 is 18. And that is the sum of the coefficients. Are we good, everyone? Any questions or any comments? So to find the constant, we plug in 0. To find the sum of the constants, sum of the coefficients, we look in p of 1. What if I want to find some of the odd term coefficients? Like I want to find a sub 1 plus a sub 3 plus a sub 5 plus a sub 7, blah, blah. Okay. Again, for the time being, I'm going to move on, but but in the class, we go over finding some of the odd term coefficient and the even ones. Okay, now let's take a look at this problem here. This involves the division of the polynomials, right? So the question says, find the quotient and the remainder when x plus 6 is divided into 3x squared plus 3x minus 7. Okay. Can you divide it? Absolutely, we can divide it, right? Let's actually divide this. It's not that bad. It's a quadratic, dividing it by, but of course we are going to have another method to solve. We are going to use division algorithm. But for those who really enjoy the long division, be my guest. So let's divide it, right? Now, if you are going to divide the polynomial doing long division, this is what we are going to do. So again, the constant part, don't worry about it. X, 3x squared. So to get rid of 3x goes into 3x squared, 3x times, right? So we get 3x squared plus 6 times 3x is 18x. Let's subtract it. 3x squared will cancel. Negative 15x minus 7. We bring the 7, negative 7 down. Now, x goes into negative 15x, negative 15 times, right? So we have negative 15x minus 90. Okay. And then let's subtract it. Again, cancels. So we get 90 minus 7 is 83. So that means the quotient is, in my right, is q of x is equal to 3x minus 15. Then r of x is 83. Now, this is one way to solve the problem. The other way is, let's use the division algorithm we just learned in the beginning, right? So we can say that our polynomial, let's say p of x is equal to 3x squared plus 3x minus 7. And our quotient, our divisor, if I knew the quotient, I wouldn't be divided. So divisor is x plus 6. Now, remember, in the division algorithm, the number you are dividing, I think it's dividend, right, is equal to divisor times the quotient plus the remainder, right? Remember what we said? Our remainder, we are dividing it by a linear equation. So your remainder is going to be a constant. Okay, keep that in mind. Now, p of x, again, my divisor is x plus 6. I don't know my quotient, assuming we didn't do anything before that, plus the remainder. Okay, again, remainder is going to be a constant. Keep that in mind. So let me write this as a constant here, so just okay. Or actually, sorry, I changed my mind again. Let's go to our x. Okay, now remember, I'm interested in, because I'm interested in the quotient here, that's what I divide. If I just want to find my remainder, right? So the question here, asking for a quotient, that's why we divide it here. Okay, but to find the remainder, if the question is just asking for a remainder, you don't need to do the long division. Let's use the division algorithm. Okay, remember, I'm interested in r of x, so I do not care this part here. So to get rid of this x plus 6 times q of x, what do I need to do? Assuming we don't know the quotient, we want to get rid of this product here. To get rid of a product, you want one of these to be a 0, right? And this is going to be a 0. When I don't know what this makes this a 0, assuming I don't know the quotient, I didn't do any of this. To make this, it is easier to make this one a 0, right? Which means x equals negative 6. So p of negative 6 is equal to negative 6 plus 6 times q of negative 6 plus r of negative 6. Now, here is a 0 because this part is a 0, 0 times anything is gone. So I know that p of negative 6 is equal to r of negative 6. Now, p of negative 6, just plug it in, right? 3 times negative 6 squared plus 3 times negative 6 minus 7. So we have 3 times 36, okay? 3 times negative 6 minus 7. Here is 90 minus 7, which is 83. Okay. I didn't want to multiply here because I just want to use that. This is 30, so 30 times 3 is 9. Again, Because the question is asking for a quotient, long division, you have to do the long division. Okay. Next problem. So let's skip that problem. Let's take a look at here, right? Now you can see that because this one I want to show you why we don't want to divide it. Again, not the previous question I skipped it because it was a repetition here. Because of the time being, we don't have enough time. Now find the remainder when f of x is divided by 2x minus 4. Again, this is the degree is 10, and this one we have a linear equation. If you do the long division, you are going to do this like 9 times or something, right? Do the divide 9 times. So instead, let's use the division algorithm. F of x is equal to 2x minus 4, my divisor, times the quotient. Remember, I'm dividing it by a linear equation, so my remainder is going to be a constant. Again, to find the remainder, I don't care about this part. To get rid of it, we plug in x equals 2. So, okay, that means f of 2 is equal to r of 2. So we have 2 to the 10 minus 2 times 2 to the 5 plus 3 is equal to remainder, right? So we have 1024 minus 64 plus 3. I hope that makes sense here. So I think we have 960 plus 3 is 963. Sorry. Okay, let's move on again. Now let's take a look at the question here, right? The question says find the remainder when x to the 100 is divided by x minus 1 times x minus 2. Same idea. We are going to use division algorithm. X minus 1 times x minus 2 times quotients that we don't know. Now the remainder function. Now the difference between this question and the previous one is this one here, we are dividing by a quadratic. If you are dividing it by a quadratic, then your remainder can be linear or a constant. But you have to assume start with the linear part, right? If it turns to be a constant, that's fine. Okay. And remember, so we're going to write x to the 100 is equal to, again, x minus 1 times x minus 2 times q of x plus ax plus b. This is my remainder function, right? Okay. Okay. Are we good? Now, that means, again, I have 2 unknowns here, right? So we need to figure out a and b. If a turns out to be 0, that's fine, but we cannot assume it is a constant. Now, I don't care about the quotient, so I need to get rid of this part. To get rid of it, then we are gonna plug in values, right? So one value that will get rid of this product here is when x is equal to 1, right? So when x is equal to 1, I get that 1 to the 100 is equal to, this one is 0 now, because 1 minus 1 is 0, this is gone, a plus b. And when x is 2, we get 2 to the 100 is equal to 2a plus b. Then all we have to do is just subtract it, right? So when we subtract it, we get that a is equal to 2 to the 100 minus 1, b is equal to what? 0, 1, see that? So b is going to be, remember it is 1 minus a, which is 1 minus 2 to the 100 minus 1, which is equal to 2 minus 2 to the 100. So that means my remainder is 2 to the 100 minus 1x plus 2 minus 2 to the 100. Okay. I hope that makes sense. The numbers doesn't look very nice, but don't worry about it, okay? That is the correct answer. Again, at this point, because this is level 1, we assume that students can solve 2 equations to unknowns. Okay, this is from, again, the division problem. This one, This is a division problem with, we are dividing it by a cubic one, right? So when we divide it by cubic, then your remainder should be a quadratic. Okay, quadratic, linear, or constant. So again, f of x is equal to now x minus 1, x minus 2, x minus 3 times some quotient, plus remainder is going to be in the quadratic form, right? Because we are dividing by a cubic. So again, the goal is to get rid of these one by one. So we need to get rid of this one to find a, b, and c. Now with f of 1, then we get that is going to be equal, this is gone. It is a plus b plus c, which is given, which is a 2, right? F of 2, again, this part is gone. So we have 4a plus 2b plus c, which is equal to 3. And finally, f of 3 is equal to 9a, 3b plus c, which is equal to 5. Okay. I hope that makes sense. So we have 3 equations, 3 unknowns, which is we can solve it, right? So if I subtract, so let's say this is equation 1, equation 2, and equation 3. If we do 2 minus 1, then we get that 3a plus b is equal to 1. Now, most students, they do one more and they try to plug it in. But notice that if 3a plus b is 1, in here I have 9a plus 3b, right? If I multiply this one by 3, I get that 9a plus 3b is equal to 3. So then I plug it in here. So that means c is equal to 2. If c is equal to 2, we plug into the first equation, then we get that a plus b is a 0. Remember, we found that 3a plus b is a 1. If I subtract it, I get that using a plus b is 0, 3a plus b is 1. So using this, we get that a is equal to 1/2. If a is 1/2, b is negative 1/2. So then we are done. Our remainder is 1/2 x squared minus 1/2 x plus 2. This is the remainder. And that makes sense because we have a cubic equation here. So having a quadratic remainder makes sense, okay? Okay, next. I'm going to skip this. So here is the Vietas. Let me go back to Vietas here. Now, remember that everyone knows the quadratic formula, right? So we know that ax squared plus bx plus c is 0. Remember, when we find the roots, we said that it is negative b plus b squared minus 4ac over 2. And then the second root is the one with the minus, right? Okay. Now pay attention, if we add this, then what happens is this part will cancel. So we end up with negative 2b over 2. Sorry, this is 2a. I don't know why. Okay. Then that means we get negative 2b over negative 2a, which is negative b over a. And if we multiply this, it is multiplied like difference of squares. So we get c over a, right? Now, sum of the root is negative b over a. Product of the root is c over a. Okay. This is what the formula says. But in this formula, it is more like a general. We have an n degree equation, n degree polynomial. So sum of the roots, no matter what the degrees, is always negative a sub n minus 1 over a sub n. When we multiply the roots 2 at a time, it is a sub n minus 2 over a sub n, and then it goes on. Then if I want the product of the roots, then that means it is depend on if it's an even degree or an odd degree, then it is negative 1 to the n times a sub 0 over a sub n. Okay. So this is what we are going to use in the coming question. Like during the class, I go in more detail. but let's go over this. Okay, so the vietas allow us to solve to solve this product of the roots, sum of the roots, without finding the roots, right? Because you're not necessarily gonna get numbers that are like integers, or you're not necessarily gonna get rational numbers, right? So we need to, we are using vietas to find the sum or the product relation with to find these values without actually finding the roots one by one. Okay, but again, the questions here is the questions with the vietas. You will only use the vietas in the beginning, right? The rest is the algebraic manipulation. That's what we are going to teach here. How we're going to, because the vietas part is just fun. We are going to write here is sum of the roots, product of the roots. The rest is how it depends on how well you can manipulate the equations, right? Now, I hope that makes sense. Okay, let's solve this question really quickly. So in the problem here, it says find a plus b, a times b, a and b are the roots. A plus b is sum of the roots. So we know that sum of the root is negative b over a, so it's 3 here, right? So in the class, I asked the students in the beginning, the first 2 examples, we asked them, so what is the coefficient and so on, we go over. And then the product of the root is negative 1 over 3. Okay. I hope it makes sense. For part B, the question is find the quadratic by finding a squared and b squared, whose roots are a squared and b squared. Again, I don't care about the roots as much, but if I want to find a quadratic that these are the roots, that means I can find sum of the roots and product of the roots, and I can write the quadratic equation in that. Then the sum of the squares is going to be a plus b squared minus 2ab, right? And a squared b squared is simply a times b squared. Remember, I find a plus b in the beginning. So this is 3 squared minus 2 times negative 1/3. So we have 9 plus 2 over 3. So my new quadratic equation has sum of the roots that is 29 over 3. Okay. And the product of the roots a times b squared, so it is negative 1 over 3 squared, which is 1 over 9. Oh yeah, it is negative 1. Thank you so much, James. That was correct. It is negative. I don't know why I divide by 3. Thank you. It is much better to deal with than a fraction. 2 times negative 1, right? Oops, it's squared against. So then this is 9 plus 2, which is 11. It should be correct now, right? Again, correct me if I'm wrong. So this part here is also easier. It is negative 1 squared, okay, which is 1. So sum of the root is 11, product of the root is 1. Then that means my new quadratic is going to be x squared. Remember, product of the sum of the root is 11. So it is negative 11x, product of the root is, okay, here's my quadratic. So we found the equation using the sum of the roots and product of. Like I said, the vietas are done here, right? We only use vietas here. The rest is, like I said, the algebraic manipulation. And that part requires a lot of practice. So part C, saying 1 over a plus 1 plus 1 over b plus 1. So I ask the questions, how do we approach this? They automatically say, get the common denominator. If I get the common denominator, I get a plus 1 plus b plus 1 divided by a plus 1 times b plus 1. So the top part is a plus b plus 2. The bottom is now going to be ab plus a plus b plus 1, which I already know all of these, right? A plus b was 3 plus 2. A times b is not 1/3, right, guys? It is negative 1, okay? So it is negative 1 plus 3 plus 1. This is simply 5. Okay. So then I will stop here. So then we go over the questions here, finding the roots, finding the fourths, sum of the fourth. Or like I said, to solve these questions, you just write the vietas and then you are done. Then we are gonna go over, then you have to see how can you use that to find the value here. Okay. Oops, did I do it wrong again? 5/3. Of course it is 5/3. Thank you. Apparently I cannot add. Sorry guys, I was rushing. Okay. Now, but thank you again for correcting. That means you're paying attention. Okay. Now, again, like I said, so the questions gets quite challenging as we move on. Now, before we can, so I'm gonna open the floor for questions. So any questions about the camp? And again, the topics are listed on our website. If you please, if you have any questions regarding that, please refer to our website. Any other questions? We have an in-person and online option for level 1. In-person is in the last 2 weeks in June. Any questions or any comments? You can use the chat box or speak up, whatever you prefer. These are the easier portions of it, right? As we go along, it gets harder. So for example, this question is pretty challenging. In level 1, we cover questions from last 5 problems in state, like similar to those level, is last 5 questions in state math counts and mostly national math counts, and then last 5 on AMC or last 7 on AMC. We also have some earlier AMY questions 1 through 5 or 1 through 7. Vietas give us the, I hope I answered your question, Nathan. So like it's, but the vietas are basically telling us giving us an idea of how the like sum of the roots, product of the roots, okay, and then and when we multiply them 2 at a time, okay, basically give us some sort of like idea about the roots here. Nathan, was I able to answer your question, or Benjamin? By the way, this is our website. It is very detailed. If you go, it is every topics is listed. We have sample problems in level 1. You can refer to that. But here is our contest maths curriculum for students who are in 301 and 401. For students who are in 401, can take the level, can enroll level 1 right away. For 301, you may need an approval. I mean, you may, depending on, I mean, we approve most of the students, but unless if you're in 301 and didn't perform well, then we might contact you. But students in 301 and 401 can take the level 1. It assumes it is the completion of pre-algebra, obviously, and then given AMC8 score of more than 17. Okay. If you're not sure if that's the right level, there is a test. So you are more than welcome to take that test. You can see, let's say you took the level 1 test and you scored more than 90%, then we will ask you to take the level 2 test. I mean, we are going to have a level 2 test and we might ask you to take that. So we don't want you to take a class where it is too easy or too difficult. It's just, it is important to take the right level course during these summer sessions. The classes are 3 hours, each session is 3 hours, like morning is 3 hours long, the afternoon is 3 hours, but we do give a break at the end of each hour. And we have Kahoot quizzes or Nearpod quizzes in the class. Okay. We might also have a warm-up at the end of warm-ups in the beginning of the class, but at the end of the 2-week session, there's going to be a test.